Hello everyone. I hope all of you are fine. In the last class, we had done what is periodicity, and we had done one periodic property, that was atomic size or atomic radius. Now today we will be discussing another periodic property, what is called ionization enthalpy. This ionization enthalpy is also called ionization energy. Ionization energy, or also called ionization potential. Okay, so what is meaning of this ionization energy or ionization potential? The new term is ionization enthalpy. You will know about enthalpy later on in standard 10, 11, but it is related with the heat or energy required. Now, what is meaning of ionization energy? Take one example. Suppose we have sodium atom. We say that sodium atomic number is 281. To attain stability, sodium loses one electron to form sodium ion. This is how we say. But thing is not so simple. What happens? Sodium is solid, and each sodium atom is surrounded by large number of other sodium atoms, and they are held together by a bond called metallic bond. So if we have to remove electron from sodium, the electron is held by the nucleus by some force of attraction. So if we have to remove electron from the last shell of the sodium, we need some amount of energy, and that energy can be called ionization energy. But the thing is not so simple as I have written here. What I said, that sodium is in solid state. It means one sodium atom is surrounded by a large number of sodium atoms, and they are held together. There is some force of attraction between sodium atoms. So when we supply some amount of energy, and say we have to convert this sodium solid into gaseous state, then we will need some amount of energy to convert this sodium solid into gaseous state, and we need some amount of energy for that, what is called heat of sublimation. And in gaseous state, now the particles are quite far from one another. So in gaseous state, sodium is free now, sodium is isolated. So in the beginning, when you supply some amount of energy, a part of the energy used to convert solid sodium atom, which is surrounded by large number of sodium atom, into gaseous atom. In gaseous state, the sodium is isolated, means there is no interaction between the sodium atom and this sodium atom. Sodium is free now. After that, whatever energy you supply, that energy will be used to remove electron to form sodium ion in gaseous state. So whatever energy is required in this state, that is to remove one electron from free sodium atom, and it will be free only when it is in gaseous state. it will be free, it will be isolated only when it is in gaseous state. So the amount of energy required to remove the most loosely held electron. So when I say about most loosely held electron, definitely it is the last cell electron. So the amount of energy required to remove the most loosely held electron from the isolated gaseous atom to form isolated gaseous ion, sodium ion in gaseous state, that amount of energy required is called ionization energy or ionization potential or enthalpy of ionization or simply ionization enthalpy. Okay, so this is meaning of ionization. Now, what information, why do we study this? How it will help us to know something about sodium atom or any other metal atom. You know, we say the metals are electropositive, means they lose electron to form metallic ion, positive ion. Now, is it that all the metals are equally electropositive? No. For example, sodium is more electropositive than aluminium. Now, what does it mean? It means the amount of energy required for sodium, gaseous sodium atom to convert into sodium gaseous ion is less than the amount of energy required to remove electron from the aluminium. So, ionization enthalpy will tell you that how easily a metal can lose its electron. So, if ionization enthalpy is low, it has more electropositive nature, it means it is more metallic in nature. So, lower the ionization enthalpy, more is the metallic nature, more is the electropositive nature. Now, what are the factors on which the ionization potential will depend? Factors. First is atomic size, R. Now, if atom is small, it means the last cell electron is very close to the nucleus, and due to this force of attraction is strong, and if the force of attraction is strong, we need more amount of energy to remove that electron. So there is inverse relation between the atomic size and the ionization potential. Smaller the atom, higher is the ionization potential. So ionization energy or ionization potential is inversely proportional to R. Second, nuclear charge. Okay, nuclear charge means how many positively charged electrons are present in the nucleus. With more number of protons in the nucleus, the force of attraction between the nucleus and the last cell electron will be strong and it will be difficult to remove electron. So with increase in nuclear charge, the ionization potential will increase. So ionization potential or ionization energy is directly proportional to Z. Okay, and third, it will depend on the number of cells. Okay, and this number of cells, in fact, it is related to, I gave you in the previous class what is called shielding effect. If we have more number of intervening cells, that is number of cells between the nucleus and the valence shell electron. If you have more number of cells, the nucleus is screened. So even if we have large number of protons in the nucleus, if the nucleus is shielded by number of intervening cells, then the force of attraction, actual force of attraction on the valence shell electron will be less than the expected. That's meaning of shielding effect. Now, how ionization potential will vary, will change in a period and in a group. So variation of ionization energy or ionization potential across a period. As we move from left to right, atomic size decreases, and due to decrease in size, the distance between the nucleus and the valence shell electron will also decrease, but force of attraction between the valence shell electron and the nucleus will increase, and so more amount of energy is required to remove the electron. Okay, so what will happen across a period? Due to decrease in size, not only there is decrease in size, there is also increase in number of protons in the nucleus. So both the factors, that is the radius is decreasing, nucleus charge is increasing, and due to this, what will happen? The ionization potential will increase, ionization potential will increase from left to right. So increases. It means if you take second period, in the second period you have lithium and here you had neon. So left to right, as you move from left to right, what will happen? Ionization potential will increase. And here till neon also will increase. You know, here you have halogen. After halogen you have here neon. Neon will have exceptionally very high value of ionization potential because it has octet configuration. Means the configuration is stable, and if it is stable, it is very difficult to remove electron, and that's why, you know, the neon will not form any positive ion, and that's why we don't have any compound of neon. Down a group, as we move down a group, the size increases. Not only size increases, the number of cells are also increasing. And so the last cell electron, the distance between the last cell electron and the nucleus is increasing. So even if we have increase in number of protons inside the nucleus, due to intervening cells, due to shielding effect, an increase in distance of the valence shell from the nucleus, the force of attraction will decrease. And due to this, less amount of energy is required to remove electron. Hence, down the group, ionization potential will decrease. Okay. So in any period, the first element, that is alkali metal, will have the lowest ionization potential, and the last element will have the highest ionization potential. So what does it indicate? It means as you move from left to right, the extreme left you have metal, which has high tendency to lose electron. Low ionization potential means high tendency to lose electron. And as you move from left to right, ionization potential is increasing. It means tendency to lose electron is decreasing, which in turn means the metallic character is decreasing. And if metallic character is decreasing, non-metallic character is increasing. That's why you will see in the periodic table, and the left portion of the periodic table, left part of the periodic table, we have metals, and in the right portion of the periodic table, most of them are non-metal. Now, down a group, in any group, the first element of that group will have the highest ionization potential. And as you move down the group, the last element will have the lowest ionization potential. For example, suppose if you take here first group, I'm not writing all the elements every time: hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. The francium should have the lowest ionization potential. If we leave this francium is radioactive. If you take cesium, from hydrogen to cesium will have the lowest ionization potential. Lowest ionization potential means very easily electron can be removed, and that's the reason cesium is used in photoelectric cell. When light falls on it, very easily electron can be ejected. That we will see in detail in standard 11, what is called photoelectric effect. So once more, from left to right, ionization potential will increase. Down the group, ionization potential will decrease. Now, what type of question comes from here? You may be asked, suppose if I write here some elements, suppose if I write lithium, and say you have beryllium, okay, and say oxygen and fluorine, and you are asked to you may be asked like this: name the element which has the lowest ionization potential. So what we have to see is that all these elements are from the same period. Now you have to see which has the lowest atomic number. This is 3, 4, this is 8, this is 9. But all of them are in the same period, in the second period. So lithium will have the lowest ionization potential and fluorine will have the highest ionization potential. Okay, or maybe that you will be given 3, 4 elements either from the same group or from the same period, but not in the same order as they are present in the periodic table, and you are asked to arrange them in increasing or decreasing order of ionization potential. Okay, now it is not necessary that always element will lose only one electron. In the case of magnesium, we say magnesium loses 2 electrons to form magnesium ion, isn't it? Atomic number is 12, so it is 2, 8, 2. It will lose 2 electrons so that it becomes 2, 8. Now, if more than 1 electrons are lost, then the loss of electron will not be in a single step. The electrons are lost one by one. Means first magnesium will lose 1 electron, then the second electron. In the case of aluminium, it loses 3 electrons to form Al3 plus ion. So first it will lose 1 electron, then second electron, then third electron. So if sodium loses 2 electrons, magnesium, this is magnesium gaseous. First of all, 2, 8, 2, it will first lose 1 electron so that it forms Mg plus in gaseous state. Configuration becomes 2, 8, 1, and then again it will lose one more electron to form Mg2 plus in gaseous state. The amount of energy required here, we will call it as first ionization energy, and this will be second ionization energy. Now will these two will be the same or different? Let's take it like this. Here you have number of protons, you have 12, number of electrons also 12. Here number of proton 12, but number of electrons 11. Here number of protons you have 12 and electron 10. Now what you find here is, in this case 12 electrons are attracted by 12 protons. Here 11 electrons are attracted by 12 protons. So definitely in this case the force of attraction by 12 proton on 11 electron will be stronger than that of the force of attraction by 12 protons on 12 electrons. So after loss of one electron, the force of attraction on this electron becomes stronger. So second ionization potential, it will be difficult to remove electron from here, isn't it? Because after loss of one electron, remaining you have 11 electron, but the number of protons remains the same. So after loss of one electron, the force of attraction on the remaining electron will increase, and so the second ionization potential will be higher than the first ionization potential. This is called successive ionization potential. Similarly, in the case of aluminium, we'll have 3 successive ionization potential: first, second and third. Third ionization potential will be greater than that of second, and in turn second will be greater than that of first ionization potential. Okay, so I will keep this much today. I have already uploaded the different type of question answer from this chapter in the previous video only. If you have book exercise, you will find number of questions are given from ionization potential and also from the atomic radius. You please solve that, and if you have any problem, okay, you just mail me or WhatsApp me. Okay, till then, thank you very much.